Hey guys, I hope you had a great weekend. Before we get started with the notes, I want to make sure that you know how to go in and look at your graded assignments. So go ahead and log into your Google Classroom and go to your classwork, and it should pull up your grade in the top right hand corner. Also, you should have gotten an email with that grade as well. And then you can click on your assignment and it should pull back up your Google Slide assignment. And any question that you got wrong, I highlighted red. And on some of them, I actually wrote a comment as to why you got it wrong, or what you could have done to fix it. Okay? If you are interested in correcting these, please let me know. You can text me or email me, and I'll reopen them back up for you to go in and correct it. Just make sure that whenever you correct it, you do it in a different color. That way I know that it's been corrected. Okay? Anyways, let's go ahead and get out your journals and turn to your unit title page. The lesson today is 1.3 one-step equations. Okay, hopefully you mastered one-step equations in like 7th and 8th grade. But if not, I just want to make sure, because you have to have this foundation before we can move on to anything else. So go ahead and add that into your journal. Alright, and then at this time, make sure you have algebra tiles. If not, we'll get them passed out. Up until this point, we have been working with polynomials and just combining like terms. So like you would combine all your x squareds together, and then your x's, and then your 1's. But we didn't actually solve for x. We didn't know what x actually equaled. It didn't equal a number or a value. But now we're going to start solving and figuring out, well, what does x equal? So we're going to be doing one-step equations. Hopefully you mastered these in 7th and 8th grade, but if not, that's okay. I just want to make sure that you have this solid foundation before we start moving on to harder equations like multi-step equations. So let's go ahead and get started. An equation is a mathematical statement composed of algebraic and or numeric expressions set equal to each other. So now we're actually going to have an equal side, and we're going to have a left side and a right side. To evaluate means to determine the value of a variable. So we're actually going to get x equals some number. That's why evaluate has the word value in it. And then finally, a solution is a value we can put in place of a variable to make an equation true. So what does x mean, and why do we solve algebra equations? Okay, so x is just like a missing number. Basically, you could ask yourself, like, I know something plus 5 equals 8. Well, what would that something be? What plus 5 equals 8? So as we get older and move into high school, instead of just saying what's that something or making it as a shape, we call this something missing as x. So anytime you see a variable, it's actually representing something that we don't know yet, that we're trying to figure out what it is, okay? And we can work algebra to figure out what that x is as a number. So if we did this and solved it, we would know, well, 5 plus 3 would have to equal 8, so x would have to be 3. Okay, so we're going to look at this with algebra tiles. I need 1x, so go ahead and get this out, or just draw a picture of it. 1 positive x and 3 positive 1's equals 5 positive 1's. So obviously this is a problem we can just do in your head, because we know what plus 3 equals 5, and the answer would be 2. But let's go ahead and look at it how we would do this with algebra tiles, so we can start off really simple and then move on. Alright, so the goal is to figure out what x equals. So I'm going to go ahead and circle x, because I want to get this by itself. I want to get x all alone so I know what it would be equal to. So we have to get these 3 positives on the left and move them to the right. Well, in order to do that, we have to actually add in a 0 pair. So we're going to add in these negative 1s. Because I know a positive 1 plus a negative 1 would cancel. But whatever you do to one side of the equation, you have to do to the other. Okay, it's kind of like working out your body. You wouldn't want to work out just your right arm over and over again and not your left arm. Okay, you'd have a wimpy left arm and then a huge right arm. You want to keep your body balanced, and just like an algebra equation, you want to keep each side of the equation balanced as well. So we're going to add in 3 negative 1s onto the right side. Okay, now let's cancel off our 0 pairs. So I've got positive and a negative, positive and a negative, positive and a negative. So all that would equal 0. Now let's cancel off our 0 pairs on the right side. So there's a positive 1, negative 1, positive, negative, positive, negative. So I'm just left with positive x equals 2 1s. So we can actually see that we would get x equals 2. Okay, then you can plug it back in and check it. Does 2 plus 3 equal 5? And yes, it does. Okay, moving on to this one. So now we've got 2 positive x's, and it equals 6 1s. Well, I know what 2x equals, but I just want to figure out what 1x equals. So we could divide this up into 2 groups. And same thing with the 1s. If I divide my left side into 2 groups, I need to divide my right side into 2 groups. So because there's 6 units here, if I divide them into 2, each group would have 3 units in it. So now I'm left with 1 positive x would have to equal 3 1s. And so if I actually wrote this out, I know that x would equal 3. And check it. Does 2 times 3 equal 6? Yes, it does. Alright, last example with Algebra Tiles. This time we have a negative x and 4 negative 1s equals 6 negative 1s. Okay, my same goal is to get x by itself so I can figure out what it equals. So I need to get these 4 negatives and get them to the other side. And by doing that, we can eliminate them by adding in 4 positives. Oh, let me turn that to blue. And since we added in 4 positives to the left, I need to add in 4 positives to the right. Okay, so now we can eliminate our 0 pairs. And then on the right side, I've got 1 positive, 1 negative, positive, negative, positive, negative, positive, negative. So that leaves me with a positive x, a negative x equals negative 2. So we're almost done, but I don't want to know what a negative x equals. I want what a positive x equals. So basically you need to multiply it by a negative. And in order to show that on Algebra Tiles, you're actually just going to flip it over. Okay, we're just going to change the sign and flip it. So if I flip the left side, I need to flip the right side. So I would end up with x equals positive 2. Alright, so just like everything, we don't want to use Algebra Tiles for all of our problems. We need to graduate to a algebraic method, which is the next page. Okay, so our first step is to isolate the variable. Isolate just means to get by itself. By using inverse operations. Remember, whatever you do to one side, you have to do to the other. And then you always want to check your solution. So plug your answer in and make sure that it makes sense. Okay, so we have x plus 4 equals 10. And I want to get x by itself, so the opposite of adding 4 would be to subtract 4. So if I subtracted 4 from each side, I would have 4 minus 4, which is 0, and it would leave me with 1x equals 10 minus 4, which would be 6. Alright, move on to the next one. X minus 7 equals 2. Well, I want to get the x by itself, so I need to subtract the negative 7 and bring it to the other side. Well, since it's already negative, in order to eliminate those negative 7s, I need to add on positive 7, because negative 7 plus positive 7 is 0. So I'd be left with 1x equals 2 plus 7, which is 9. Okay, now we have 5m equals 35. Well, I don't want to know what 5m equals, I want to know what 1m equals. So I need to divide each side by 5. 5 divided by 5 is 1, so I'm left with 1m equals 35 divided by 5, which would be 7. Alright, now we're going to look at these problems. So I've got n divided by 7 equals 56. So something divided by 7 equals 56. The inverse of division would be to multiply. So I'm going to multiply each side by 7 over 1. Seven divided by 7 here is 1. So I'd be left with 1n equals 56 times 7, which is 392. So that's whenever your variable's in the numerator. Let's look at an example when the variable's in the denominator. This time I have 60 divided by p equals 6. Well, let's just think about it and what would make sense here. 60 divided by some number equals 6. I have to figure out what that number is. So what we would do is just divide 60 divided by 6, but let me show you why algebraically. So because we have p in the denominator, we need to multiply each side by p. So I would have p divided by p is 1, and I would have 60 equals 6p. So let me rewrite that right here. Oh, and I forgot to write multiply up here earlier. So we multiplied by 7. Okay, back down here to this middle problem. So now I have 60 equals 6p by just rearranging the equation. And if I wanted to figure out what p equals now, I could divide each side by 6. So 60 divided by 6 would leave me with 10. So basically, anytime you have a variable in the denominator, you could have just divided 60 by 6, and that would have given you your answer. Okay, last one. I've got 2/3 x equals 10. And there's two ways to solve this one as well. So I could multiply by 3 and then divide by 2, or I could just multiply by the reciprocal, which is my favorite way of doing this. So I'm going to multiply each side by 3 over 2. 3/2 times 2/3. What is that? Well, if you multiply straight across, 3 times 2 is 6, and 2 times 3 is 6, and 6 divided by 6 is 1. So anytime you multiply by the reciprocal, you're actually just getting it to equal to 1. So I'd be left with 1x equals 10 times 3/2. So multiply straight across, you'd have 10 times 3, which is 30, divided by 2. And 30 divided by 2 is 15. Okay, and then check your answer. Make sure that 2/3 of 15 is 10. And it is, so you know you did it correctly. 4 more, and we'll be done with the notes. So I have x squared equals 36. Well, the inverse of squaring something would be to take the square root. So I would take the square root of each side. And whenever you take the square root of a square, you're actually just getting what's underneath it. So we would just be left with 1x equals the square root of 36, which is 6. And then you could do the opposite. So if I have the square root of m equals 9, the opposite of taking the square root would be to raise it to the second power. So I need to raise each side to the second power. The square root of m squared is just m, and then it would equal 9 squared. So 9 squared is 81. So the opposite of taking the square root would be to square. And then finally, we have n cubed equals 8. So the opposite of cubing something would be to take the cube root. So I need to take the cube root of each side. Well, the cube root of n cubed is just n, and then the cube root of 8 is 2. Okay, and remember, you can always plug in your answer and check it. Make sure that 2 cubed equals 8. 2 times 2 times 2. And it does. Alright, last one. The inverse of the cube root would be to cube it. So I'm going to raise each side to the third power. The cube root of x cubed is just x. And then 64 cubed is 262,144. Man, that was a big number. Alright, so these are all of the one-step equations that you're going to be doing. You're going to do an iExcel, so go ahead and log in and get started. If you have any questions, let me know. Bye.